spite of the enormous scientific and technological progress in recent years, we've not yet explored outer space. It is very expensive to fly into outer space. A long stay in it is very harmful to people, and economic benefits are out of the question. However, a number of countries and various companies today are developing technologies that can fundamentally change our current situation in space. These are the technologies I'm going to tell you about right now. Let's go! We start, of course, with the space elevator. Having read just the name of this video, you may have guessed that it would definitely be mentioned. Many science fiction writers have dreamt about space elevators for a long time. Konstantin Tsiolkovsky spoke about it the first time in 1895. This hypothetical design was based on the application of a rope stretching from the planet's surface to an orbital station. The way it would work is like this. A rope is fixed at one end of the Earth's surface, and the other end would be fixed at a point immovable relative to the planet. And above the geostationary orbit, due to the centrifugal force, a hoist is lifted on the rope carrying a payload. During lifting, the cargo would be accelerated at the expense of the Earth's rotation that would allow at a high enough altitude to send it off the planet. According to scientists' plans, such a design would reduce the cost of launching cargo into space by orders of magnitude compared to the use of rockets, which would result in the rapid development of the space industry. But if everything is so good from an economic point of view, why has humanity not yet built a space elevator? The thing is that we lack today a material durable enough to make this idea reality. We need something that would be about 100 times stronger than steel, and it must be much lighter. Today, scientists are studying the application of carbon nanotubes, but the technology to produce them in industrial quantities and weave them into cables is only in the beginning stages. Some minds are so convinced of the success of this endeavor that in 2012 Japan announced it will build a space elevator in 40 years. They are simply sure that in the near future, it will be quite easy to create a rope from nanotubes. A space elevator can also be built on other planets, and the less gravity on a planet, the faster it rotates. The easier it would be to implement construction. A space elevator can be built on Mars using existing materials, but if it would be possible to realize such an idea, then the elevator, in this case, could be used not only for launching cargo into space, but also for interplanetary trips. Some scientists have even expressed the idea of building a space elevator from Earth to the Moon, but it seems impossible. Then we have an even more promising project, which theoretically can be implemented already today on existing technologies that are able to reduce the cost of launching cargo into space with ridiculous prices: a magnetic space train. The idea is quite simple. It would be necessary to construct a suspended vacuum tunnel 130 kilometers long, inside which a module on a magnetic cushion would move at blistering speed, and as it would not meet any resistance of air, it would manage to accelerate to an improbable 32,000 kilometers per hour. The edge of the tunnel would be located 20 kilometers above sea level. At this altitude, the air is very thin, so that the train flying out of the tube will not burn from the Earth's atmosphere, and would continue to fly at a speed of 9 kilometers a second until it finally reaches space. Yes, in fact, spacecraft will literally be shot into space. This method is ideally suited for taking valuable cargo from Earth. But in order to transport people in this way and not kill them with horrible G-forces, the length of the tunnel should be about 1,500 kilometers long, and it should be raised a lot higher. Of course, it's all an expensive idea. Creating such a wonder of the world, according to analyst estimates, would cost them $60 billion and would take 20 years to complete. But the effect of the project's implementation would be simply awesome. If today the launch of 1 kilogram of cargo in space costs $11,000 at best, then the invention of the space train, that price would fall to a ridiculous $40 per 1 kilogram. Next on the list of space inventions, we have artificial gravity. Perhaps some people will be surprised, but artificial gravity in a spacecraft can be created already today using existing technologies. But why do we need it? The point is that a long stay in the weightlessness of space has a very negative impact on the human body. Rapid muscle atrophy and subsequent decrease of all physical indices begin the moment a human leaves gravity. And therefore, for long space travels, it is vital to create artificial gravity. One of the means for its implementation, which is often recalled in the works of science fiction writers and scientists, is to create a space station that would rotate around its axis. Such a rotation would lead to the constant influence on the astronauts or residents of the station by centrifugal force, which they would feel like a gravitational force. For example, in the film Elysium, a donut-shaped space city created artificial gravity exactly in this way. In the film Passengers, gravity in a giant spaceship also worked due to its rotation around its axis. As soon as the ship stopped rotating, gravity disappeared inside it. So then, why haven't we created to date artificial gravity like the Earth's gravity, on a space station for example? For that to happen, the radius of rotation should be at least 224 meters. Imagine a space station in the form of a cylinder with a diameter of almost half a kilometer. Well, it is possible to build it, but it would be very, very expensive. Therefore, scientists plan to build and design a smaller centrifuge, which will be installed as a new module on the International Space Station. Although it will not provide the same gravity level as the Earth's, it will at least be able to create half the gravitational force. Artificial gravity will help humanity build entire comfortable cities, with near-Earth gravity in space in the near future. And that is why their creation is only a matter of time. If you didn't know it, asteroids are real treasures. In fact, the most incredible treasure trove in history flew past us, and no one even bothered to catch it. On July 19, 2015, a platinum asteroid worth about $5 trillion zoomed past Earth. This knowledge haunts many countries and corporations, which are already today counting on technology to mine asteroids in the near future. If we have the technology, we could extract elements such as platinum, cobalt, and other various rare minerals from these passerby asteroids, and deliver all that precious cargo back to Earth. This could bring an incredible profit. In 1997, a relatively small metal asteroid was spotted in our solar system, with a diameter of 1.5 kilometers. It was made up of various metals including precious ones. We calculated to be worth $20 trillion. In essence, all the gold, cobalt, iron, palladium, and platinum, which are now extracted from the upper layers of the Earth, are the remnants of asteroids that crashed into the Earth during the early meteorite bombardment. After the cooling of the crust, a huge amount of asteroid material fell on the planet, and today this is what we are mining. But the Earth will run out of resources sooner or later. In 2004, the world iron ore production exceeded 1 billion tons. For comparison, one small asteroid of class M, 1 kilometer in diameter, may contain 2 billion tons of iron and nickel ore. But the largest known metallic asteroid, called Psyche, contains 100,000 times more ore than is present in the Earth's crust. Just think about the prospects it opens for the space industry. The amount of ore in the asteroid Psyche would be sufficient to satisfy the requirements of the world's population for several million years, even taking into account the increasing demand. And all that wealth is within our solar system. Space colonies will also be able to extract water, which is contained in huge quantities on various comets. In general, some people are so obsessed with this issue that the US Congress even developed a law stating that any resources extracted from asteroids in space are the property of the individual and organization that received those resources. All the rights belong to the miners. And this draft law has come at the right time, since nowadays it's no longer just food for thought for fiction writers, but also an object of interest for commercial organizations and the governments of a number of countries. Apart from asteroids, various planets and their natural satellites are of interest in terms of extraction of useful raw materials. Even the dry and lifeless moon has enormous reserves of valuable helium-3 in its depths, thanks to which we can get huge amounts of electric power. If it would be possible to deploy bases on the moon, which is already planned by some countries today, and start production, the population of our planet would be supplied with the lunar resource of helium-3 for about 5,000 years. The next space technology on our list will make interstellar journeys possible much sooner than you think. In 2016, Russian billionaire Yuri Milner, the late great astrophysicist Stephen Hawking, Facebook owner Mark Zuckerberg, and many outstanding scientists including Nobel laureates, launched a project aimed at the creation of a multitude of mini spacecraft that will be able to move at an incredible speed of 1/5 of the speed of light. Such a spacecraft will get to Mars in an hour, to Pluto in a few days. It would overtake Voyager in less than a week and reach Alpha Centauri in 20 years. As of today, $100 million has already been invested in this project. The launch of the mini-ships is planned in 20 years, and here is how it will look. Small vehicles about the size of a postal stamp, equipped with sails weighing only a few grams, will be launched into space into Earth's orbit. Then they will be propelled from Earth by a massive laser array. In 2 minutes of laser boost, the spacecraft will accelerate to 1/5 the speed of light, 1,000 times faster than any artificial apparatus in human history. Each probe will fly 20 years and collect scientific data in interstellar space. Reaching the planets in Alpha Centauri star system, the built-in digital camera will photograph in high resolution and send images to Earth, allowing us to look at our immediate neighbors. In addition to scientific knowledge, we'll be able to find out whether these planets are suitable for human colonization. And we would like to remind you that Alpha Centauri contains the exoplanet of Proxima b, which is considered to be similar to Earth. The project of mini spacecraft is very important, because even if the Alpha Centauri radiation is not of much use for us, at least we'll have devices that can be very quickly found anywhere in the solar system and transmit to us the necessary data. It is like sending a parcel to Mars in just 1 hour. A detailed study of our solar system will turn dreams into reality. Although this venture looks completely like science fiction, there are no scientific obstacles to its realization. Organizers and scientific consultants believe that increasingly sophisticated technologies will allow spaceships to gradually shrink in size. That's all. We'll one day be back to space technologies. And in the meantime, click the like button and subscribe to the channel. Thank you all for watching.